Ever wonder how your car's engine stays cool on a scorching day, or how your fridge keeps snacks chilled? The answer: heat exchangers. These devices are everywhere. Power plants, air conditioners, even your laptop. Silently managing heat so our world runs smoothly. Heat exchangers move heat from where there's too much to where there's too little, without mixing the fluids involved. They're the ultimate temperature diplomats, using simple science to solve complex problems. By transferring heat efficiently, they save energy, cut costs, and help the planet. From massive industrial towers to tiny electronics, each heat exchanger is tailored for its job. Next time you enjoy a cool breeze or a cold drink, thank these unsung heroes. They're a perfect example of science making life better. Sometimes hot, sometimes cool, always essential. Let's dive into the world of heat exchangers. So, what is a heat exchanger? Simply put, it's a device that transfers heat between two fluids, liquid or gas, without letting them mix. A solid conductive wall, often copper or aluminum, keeps the fluids apart, but lets heat flow through. Picture two pipes, one with hot water, one with cold. Run them side by side, and heat naturally moves from hot to cold through the pipe walls. The trick is maximizing the surface area where this transfer happens. Think tubes, fins, or plates packed tightly together. More surface area means more heat moves, faster and more efficiently. This principle is the same whether you're cooling a power plant or your phone. Engineers constantly refine designs to make heat exchangers smaller, more efficient, and more powerful. No magic, just clever science and smart engineering. If you understand this, you understand the heart of every heat exchanger. Ready to meet the key players? Let's meet the stars of the heat exchanger world. First, the shell and tube heat exchanger, a bundle of tubes inside a cylinder. One fluid flows through the tubes, another around them. It's tough, reliable, and perfect for high-pressure jobs in industry. Next, the plate heat exchanger, thin, corrugated metal plates stacked together. Hot and cold fluids flow in alternating channels, maximizing surface area for rapid heat transfer. You'll find these in food processing and HVAC systems. Finally, the finned tube heat exchanger, tubes with metal fins attached. Used in car radiators and air conditioners, the fins boost surface area so heat can jump from liquid to air efficiently. Each design has its specialty: shell and tube for brute strength, plate for compact efficiency, finned tube for liquid to gas transfers. Engineers choose the right type based on fluids, temperatures, pressures, and maintenance needs. The right heat exchanger keeps everything running safely and efficiently. Science is about using the right tool for the job, and these are some of the best. Whether in a refinery or your living room, these designs make modern life possible. Let's see how they work in action. Imagine a dance party. On one side, the hot team dances energetically. On the other, the cold team waits, calm and cool. A thin metal curtain separates them. They can't mix, but they can transfer energy through the curtain. As the hot team dances, they shake the curtain, passing energy to the cold team, who start dancing more energetically. The hot team cools down, the cold team warms up, all without crossing sides. That's exactly how a heat exchanger works. Heat moves from hot to cold, across a barrier, without mixing. Want to make the transfer faster? Make the curtain bigger, more surface area, or use a better material, higher conductivity. The goal? Maximize energy transfer, minimize losses. This simple dance is the heart of every heat exchanger. It's all about efficient, controlled energy flow. Now, let's see where you encounter this dance every day. Heat exchangers are everywhere. Let's spot a few. In your car, the radiator, a finned tube exchanger, cools engine fluid by transferring heat to the air as you drive. At home, your air conditioner uses two heat exchangers. One inside, evaporator coil, absorbs heat from your air. The other outside, condenser coil, dumps it outdoors. Your fridge works the same way, moving heat from inside to your kitchen. Modern buildings use heat recovery ventilators, heat exchangers that pre-warm incoming fresh air with outgoing warm air, saving energy. In industry, heat exchangers control temperatures in power plants, chemical factories, and food processing. They cool machinery, pasteurize milk, and even warm swimming pools. From massive plants to tiny gadgets, the principle is the same. Move heat efficiently, save energy, and keep things running. They're the backbone of comfort, safety, and sustainability. Next, let's see how heat exchangers help us reach for the stars. Here's a real-world challenge: cooling a satellite in space. Satellites face extreme temperatures, blazing hot on one side, freezing on the other, while sensitive electronics need a steady, room-like temperature. Our team designed a system using custom plate heat exchangers and special fluids circulating through tiny channels in the electronics. Heat was picked up, transferred to a second fluid loop, and carried to radiator panels on the satellite's exterior. With no air in space, these panels radiated heat away as infrared energy. Precision was critical. The system had to keep temperatures within half a degree. We tested it in a giant vacuum chamber, simulating space. When the system held steady, it was a huge relief and a reminder of how vital heat exchangers are. Even in space, they're not just for cars and homes, they're key to exploration and discovery. From cars to satellites, heat exchangers quietly power our world. They use simple science, heat moves from hot to cold, to solve big problems and save energy. Whether it's a shell and tube in a refinery or a tiny plate in your phone, these devices make modern life possible. The field keeps evolving, with new designs and materials pushing efficiency further. Next time you feel a cool breeze or see steam from a tower, remember the heat exchangers at work. Stay curious. Look for them in your life and think about how energy flows all around you. The principles are simple, but the possibilities are endless. Go forth and exchange some heat. The world needs your bright ideas.